So good morning everyone, good evening everyone. My voice is audible? Am I audible to everyone? Please reply. Good evening, good evening, good evening Amrit. Good evening, good evening. So am I visible, audible, everything? Tell me. Yes? Okay, very good, very good. Okay, good. So what we were covering in physics? What we were doing? Okay. What we were doing in the last class? Good evening, good evening. Very good. Okay, Harita. Yes, very good. So tell me what we were doing. According to me, I know that we have covered significant figures and rules of rounding off. We have covered number of significant digits and rules of rounding off. Rules of rules of significant figure in arithmetic operation we have covered. In addition, subtraction, multiplication, division. What are the rules of arithmetic operations in significant figures? Yes, we have done that. Okay. So tell me fast. If I write 10 point, yes, if I am writing 10.02 centimeter, how many significant figures are here? In 10.02, how many significant figures are there? 4. Very good. 4. Gravity is 32 feet per second square. If you read your books, 32 feet per second square in FPS. In FPS system, gravity is 32 feet per second square. So 10.02 centimeter. This contains 4 significant figures. Very good. So 0.023. How many significant figures are there? 0.023. 0.023. 4. Very good. Again 4. Again 4. Just a minute. Some sound is coming. Okay. Very good. In 0.023, 2 significant figures are there. In 6.023 into 10 power 23, how many significant digits are here? How many significant digits are here? 6.023. Very good, Vijay. Very good, Durga. The Gulu Padu Kavita. Okay. Sham, very good. Very good. Harita, very good. Sai Ritesh, very good. Okay, so this expression contains 6023. That is 4 significant figures. This contains 4 significant figures. Okay, let me give you one more example. 9.1 into 10 power minus 31 kg. How many significant digits are here? How many significant digits are here? 9.1, 10 power minus 31 kg. Very good. Everyone is giving me correct answers. 2. This contains 2 significant figures. This expression contains 4 significant figures. Very good. Okay. So whenever our zeros are between non-zero digits, they are significant. All the non-zero digits are significant. All the non-zero digits are significant. Very good. Why I am talking about these numbers? Do you see this is Avogadro number, this is mass of electron? They are given in scientific notation. They are given in scientific notation. Whenever you give a number in this format, A into 10 power B, whenever you give a number in the format of A into 10 power B, this number is called scientific notation. This expression, this way of writing any expression is called scientific notation. In scientific notation, we always try to keep the value of A between 1 and 10. Between 1 and 10, there should not be equal sign here. The value of A should be between 1 and 10. The value of A should be between 1 and 10. So in scientific notation, we always write our numbers like this. A into 10 power B. A into 10 power B. So all this data you are already remembering. These are in scientific notation. I can give you more example. Value of universal constant of gravitation 6.67 into 10 power minus 11 Newton meter square per kilogram square. Value of this expression is in scientific notation. 6.67 10 power minus 11. This is in scientific notation. Whenever you write a number in this format, this is in scientific notation. For scientific notation, we will always keep this number between 1 and 10. 1 and 10. Okay. So tell me, 0.023 into 10 power 6. Is this in scientific notation? Is this in scientific notation? Is this number represented in scientific notation? Is this number represented in scientific notation? No. This number is not in scientific notation. This is not in between 1 and 10. This is not in scientific notation. Not in scientific notation. Why this is not in scientific notation? Because our number is not between 1 and 10. We should convert this number in 1 and 10. Okay. So I can take this decimal point 2 places backward. So it will be 2.3 into 10 power. I am taking my decimal place backward. So decrease the power of 10. Decrease the power of 10. Now I should write 10 into 10 power 4. 2.3 into 10 power 4. 2.3 10 power 4. Is this correct? Yes, this is correct. This is correct. Okay. So it should be between 1 and 10. Okay. Let us take one more example. 5364.4 into 10 power 2. Is this in scientific notation? Is my number in scientific notation? Check whether this is in scientific notation. No, again, this is not in scientific notation. This is not in scientific notation. This is not in scientific notation. My number should be between 1 and 10. So how to convert this in 1 and 10, between 1 and 10? I should write 5.3644. I am taking my decimal 1, 2, 3 places ahead. When I am doing this, I will increase the power of 10. 3 decimal places, 2. So it should be 5.3644 into 10 power 5. 10 power 5. Is this clear? How to make number in scientific notation? How to write our number in scientific notation? Scientific notation is the format A into 10 power B. Okay. We can convert any number in scientific notation. Why we are learning about scientific notation? The question arises because sometimes there is some ambiguities about number of significant digit. So we have decided, our scientists have decided, not me, our scientists have told us to write numbers in this format and use appropriate number of significant figures. If I am writing any number like this, it means 1, 2, 3, 4, 5 significant figures are there. 5 significant figures are there. We will always write our number in decimal format. In that way, we will be sure about the number of significant digits. Okay, this is to avoid ambiguities in counting number of significant digits. Okay, so this is scientific notation. Now sometimes people ask, what is order of magnitude? Order of magnitude. Order of magnitude. Let's say if I am asking what could be the distance between two hydrogen atom in H2 molecule? What would be the distance between two hydrogen atom in H2 molecule? Can it be 1 kilometer? Can it be 1 kilometer? What will be distance between two hydrogen atoms in H2 molecule? Can it be 1 kilometer? No. No, it's not 1 kilometer, of course. So can it be 1 centimeter? Not 1 kilometer, then 1 centimeter. 1 centimeter. 1 centimeter. Again, you are replying me, that is not possible. Again, 1 centimeter is again too large distance. Okay, someone are also giving me 10 power minus 10, 10 power minus 10. So that 10 power minus 10 is order of magnitude of distance. Yes, it's in angstroms, not in picometer, it's in angstrom. It's in angstrom. Okay, when you measure the bond length in molecules, when you measure bond length in molecule, usually they are in angstroms. So angstrom is order of magnitude of bond lengths. Okay, what will be the approximate value of that physical quantity? In what powers of 10 that physical quantity should come? Those powers of 10 are called order of magnitude. For example, value of G, this number is greater than 5. Whenever our physical quantity is reported in scientific notation, it's very easy to know the order of magnitude. Suppose our physical quantity is given in scientific notation, and if A is less than 5, then order of magnitude is 10 to the power b. Straight away this 10 to the power b is order of magnitude. But if our physical quantity is greater than or equal to 5, it is greater than 5 but less than greater than or equal to 5, then order of magnitude is 10 to the power b plus 1. Just add 1 to the power. Okay. So how to find order of magnitude? This power of 10, this represents order of magnitude. If the number A is less than 5, straight away 10 to the power b is order of magnitude. If our number is greater than 5 or equal to 5 also, then the power of 10 plus 1, power of 10 whatever was power plus 1, this gives you order of magnitude. It gives you a rough estimate, rough value of the physical quantity. Okay, so you will know that what kind of instrument is required to measure that thing, around what kind of data you can get, and you can also guess, estimate some other things with this order of magnitude. Okay, order of magnitude. So if I ask you what will be order of magnitude of mass of Earth, you should remember mass of Earth. What is mass of Earth? And order of magnitude is about I think 10 power 11 times 2 something, 10 power 5 or 6 times something. Okay, so read your books, you will find mass of Earth in your books. Okay, so do we understand what is order of magnitude? Now we'll see some examples here. What is order of magnitude of this number? What is order of magnitude of this number? Values of b gives the order of magnitude? No, 10 to the power b. 10 to the power b gives order of magnitude. What is order of magnitude of this number? Order of magnitude of this number is less than 5. 2.3 is less than 5. So 10 to the power 4 is order of magnitude. 10 to the power 4 is order of magnitude. What is order of magnitude of g? Order of magnitude of g. This is greater than 5, greater than 5. So add 1 to this. This is greater than 5. Then add 1 to this. 10 power minus 10. 10 power minus 10. Order of magnitude of g, 10 power minus 10. Order of magnitude of g, 10 power minus 10. What is order of magnitude of mass of electron? What is order of magnitude of mass of electron? Give me order of magnitude of mass of electron. Give me order of magnitude of mass of electron. 10 to the power minus 30. Very good. It's roughly 10 power minus 30 kg. 9.1, it's very close to 10 now. So 10 power minus 30. 10 power minus 30. Very good. Okay, so we have covered what do we mean by scientific notation and order of magnitude. In the previous class, we have covered significant figures. Okay, so let us move on to some next ideas. Errors. Now we will understand errors. We'll try to understand errors. Okay. If I want to measure length of this pen, I'm not right now not having any scale here. So suppose you have scale in your home, you have your scale, you measure length of the pen which you are holding. You must be noting down something. You measure length of this pen. Okay, length of the pen that you are having. Okay, if you measure the length of the pen you are having, your scale, which is normally used in our daily day-to-day life, that scale has markings between 1 mm. That scales have marking of size of 1 mm. There is 0, then there is 1 centimeter written, and between them there are 10 lines. There are 9 lines, so that 10 divisions are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. So distance of 1 centimeter is divided in 10 parts in normal scales. So their measurement can give you maximum up to 1 mm precision. Or you can measure the length of pen. Suppose your pen, length of pen is suppose 10 centimeter or something. You may get this kind of data: 10.5 centimeter, 10.2 centimeter. Or suppose pen is larger, then you can get 15.3 centimeter, or even you can get 20.1 centimeter. This kind of data you can get with your normal scales. Okay, suppose whatever is the whatever data you are getting, are you 100% sure that your data is correct? Whatever measurement you are doing, it is 100% correct. Suppose you measure the pen which you have in your hand with normal scale. Suppose that reading is suppose 15.3 centimeter. We cannot be 100% sure. We cannot be 100% sure. Okay, I don't have any scale here. So if I try to measure length of this pen using my scale which I am making on this board, this is giving me about 7, I suppose. Yes, it's more than 7. If I keep this pen like this, it's more than 7 but less than 8. So 7 something. Okay, 7 something. It is more than 7, less than 8. We are not, I'm not sure here. Whenever we are measuring any physical quantity, we are never sure. We are never sure about its value, the final reading. There is always some chance of uncertainty there. This uncertainty is called error. And this uncertainty may be because of the instrument or maybe because of our carelessness. Okay, for example, here I'm making a scale here. So if I say this pen is having 0.7 mm length, 0.7 mm length, then that will be completely wrong because my scale is wrong. This length exactly, this is not 1 centimeter. I'm making this scale. This length is exactly not 1 centimeter. So if I say this length of pen is 0.7 mm, then I'm wrong. My instrument is actually faulty. My scale is wrong. Sometimes error is due to faulty instrument. Sometimes you are measuring incorrectly. There are a lot of reasons of error. And if your measurement is not perfect, you don't know the exact value of physical quantity, then the reading that you are getting, it is having some difference with the exact value. That difference is called error. That difference is called error. Error in measurement of physical quantity is the difference of actual value with measured value. The difference in actual value and measured value is called error. And why this difference is there? There are a lot of reasons why this difference may happen. We can divide reasons of error into 2 categories. One, systematic or controllable. Second, random. Systematic or controllable. Systematic or controllable. And second, random. Reasons of error may be of 2 kinds: systematic or controllable and random. What are systematic errors? If we classify systematic error, you will understand them better way. One may be due to the climate or conditions around you or environment. The other may be due to instrument. The other may be due to observation. If suppose the scale that you are using is made of steel, it's a steel scale which is designed to work correctly at 10 degrees Celsius or let's say 20 degrees Celsius. But you are using this scale in a very hot environment where temperature is around 45 degrees Celsius. So the scale was designed to be operated at 20 degrees Celsius, but you are using the steel scale at 45 degrees Celsius. So the steel scale will definitely expand. Length of any material will expand with temperature. So because of the expansion, the marking will have a bigger size than what used to be at 20 degrees Celsius. So whatever you are measuring with this scale will have some error. That kind of error are called climatic error or environmental error. Climatic error or environmental error. Then there are some problem in instrument. Suppose you are using incorrect scale. Your scale is not correct. It is made by some very illogical company who is making illogical kind of marking. 1 centimeter is not 1 centimeter in your scale. So that kind of error are called instrumental error. Then observation, we can do some incorrect observations also. Suppose we don't know how to use scale and we are doing some observation error. So all these kind of errors comes under systematic or controllable errors. Systematic or controllable error. The errors, the cause of which is already known to us, and hence we can avoid them. This kind of errors are called systematic or controllable error. They can be divided in three categories: climatic, instrumentation, observation. Climate conditions, because of climate condition we can get error, because of humidity we can get error, because of electric field, external electric fields, magnetic fields, some other effect, pressure might increase. So because of this climatic or environmental condition we can get error. How to avoid this? Control your climate around you. Try to control you can control the environment in laboratory where you are performing your experiment. Okay, you cannot control the environment of complete earth, but you can control in a limited space where you are doing your experiment. So in that situations you can control environment. That's why you can minimize this climatic errors. Use a better instrument which gives you reading correctly. So you can remove this instrumental error. You can read how to use the instrument, then you can remove this observation errors. So systematic errors or controllable errors are known to us. Their cause is also known to us. Their cause is already known to us. That's why we can control them. So this kind of errors, the cause is known, can be avoided. But there are some errors whose cause is not known to us. Cause is not known. If the cause is not known to us, then how can we avoid them? They can be happening due to any reason, we don't know. Hence, random error cannot be avoided. They cannot be avoided. We can control the systematic error, but we cannot avoid random error. So there are two types of categories of error: systematic or controllable, then random error. Is this clear? There are two types of error, which are systematic or controllable, and there are random, which can't be controlled. Okay, we can make sure that systematic errors are not happening by proper careful experiments. We can make sure that systematic errors are not happening. Okay, we can not avoid random error. Random errors are bound to happen, but they are random. Sometimes they are of positive type, sometimes they are of negative type. Sometimes you are getting more value, sometimes you are getting less value. Sometimes you are measuring more than accurate value, sometimes you are measuring less than accurate value. So they are fluctuating in their nature. Sometimes their sign is positive, sometimes their sign is negative. That's why by taking multiple readings and taking average, we can get close to exact value. So I cannot avoid random errors, but I can minimize random error by taking multiple readings and average. By taking multiple reading and average, we can minimize the amount of random error that is happening, because it is sometimes positive, sometimes negative. So when you take average, positive, negative will cancel out each other. That's why with enough number of large repetitions, we can get very close to exact value. If you control the systematic errors, and if you can avoid the random error, if you can minimize the random error by multiple measurement, then you can control you can minimize the error. Okay. If we repeat our readings n time, if we take readings n time, then the amount of error in the measurement becomes 1/n. If in one measurement the error is x, then in average of n measurement, error becomes x by n. If you are taking large number of observations, then our error becomes very small. Random error can be minimized. They can be minimized. They cannot be controlled, but we can minimize them by taking multiple readings. Is this point clear? Everyone, is this point clear? We can divide categories error in two categories: controllable or systematic, then random. I cannot control random error, but I can minimize them by taking average. Systematic error, the cause of systematic error is known to us. That's why we can control them. Okay. So after controlling the systematic error and minimizing the random error, how to represent our measured value. Now the point comes how to represent our physical quantity. If we are measuring suppose length of this pen, so how to report? How to report? We will always report our physical quantity by measuring the mean value of the physical quantity. We will assume that the mean value of physical quantity is close to exact value. Mean value of physical quantity, how to find that? Mean value is sometimes also written as L average, or people also put a bar on L to show that we are making mean value. Sometimes they just write M in subscript. Sometimes they put physical quantity in angle bracket to show we are measuring mean value. How to find mean value of any measurement? We will take the readings. How many readings you have? Suppose we have n readings, divide by number of readings. This is simple. We all know how to take mean value. Okay. We will consider the mean value as the close to exact value. Then, if we know the mean value of any physical quantity with multiple readings, then with difference of mean value with every measured reading and magnitude of this is called absolute error. Absolute error. Absolute error in first reading. For absolute error in nth reading or ith reading, I will subtract the reading ith and take magnitude with mean value. I will subtract the ith reading from mean value and then take magnitude. This will be called absolute error in ith measurement. For example, suppose we are measuring length of pen 5 times, 10.1, then we are getting 10.2. We are measuring length of pen 5 times. Third time we are getting 9.9. Fourth time we are getting 10.5. Then we are getting 10.0. I am getting length of pen 5 times. I am getting these results, these readings. Then the mean value of length of pen will be addition of this divided by total number of sample. That is 5. What will be addition of this? So it will be around, this is becoming 0.7. So 50.7. Addition of this is 50.7 divided by total number of sample 5. So divide this by 5. So 10.7 by 5. So it will be around 1 then 4. 10.14. It's something about 10.14. Is this clear? Am I doing these calculations correctly? Check. Please check. Is this calculation correct? Please tell. Calculate yourself. I am measuring length of pen 5 times. The summation of this length divided by total number of samples. This gives me mean value. Now, by taking difference of this mean value with every reading. Okay, but before that, listen carefully. 10.14, I cannot just take 10.14. Why? Every reading here has only one decimal place. After decimal, you are getting only one number here. So your answer should also remember rules of significant figure in additions. In every reading here, after decimal, I am having only one decimal number, one place, one digit after decimal. So my answer should also contain only one digit after decimal. So I should round this off to only one digit after decimal. I should remove this 4. If I remove this 4, I am getting 10.1. By rules of rounding off, I am removing this 4. I am getting 10.1. 10.1. Okay, so this is my mean value of length. Now by taking difference of every reading with mean value, I can find absolute error in every reading. By taking difference of this mean value with every reading. For first reading, what is the absolute error in first reading? 10.1 and 10.1 subtraction will be 0.0. This is my absolute error in first reading. Absolute error in second reading. Take difference of your mean value with this. This is 0.1. What is absolute error in third reading? 9.9 and 10.1. 9.9, 10.1. The difference 0.2. And we also need to take mod. Okay. Absolute error in fourth reading. Mean value, fourth reading. If you take difference, you are getting 0.4. Absolute error in fifth reading. Mean value, fifth reading. If you take difference, you are getting 0.1. So, we are measuring length of pen. Suppose, for example, I am measuring length of pen 5 times. These are the 5 readings that I am getting. To report the length of pen, I am calculating the mean value of length of pen in correct number of significant figure. Then I am calculating absolute error in every measurement. How to find absolute error in every measurement? By subtracting mean value from the reading and taking magnitude. Then the error in the physical quantity will be the mean absolute error. Mean absolute error. It's mean of this absolute error. Mean of this absolute error. It is represented by delta L mean, that is summation of all the absolute errors divided by total number of sample. Find out mean absolute error here. Mean absolute error. Errors, these are absolute errors. Take mean. Mean absolute error. Add this, divide by number of sample. 0, 1, 3, 3, 3, 4, 7. 7 plus 1, 8. So 0.8 divided by number of sample 5. 0.8 by 5. What is 0.8 by 5? 0.16. 0.16. So this is your mean absolute error. Again, remember the rules of significant digit. Here only one digit after decimal. So here also I should take one digit after decimal. So by rounding off, this becomes 0.2. By rounding off, this becomes 0.2. So mean value of length of pen, mean absolute error. Now we will report our physical quantity as mean value plus minus mean absolute error. This is how we represent the physical quantity with error. We will find out the mean value of the physical quantity, then mean absolute error. And finally, we will report our measured thing in this format. Mean value plus minus mean absolute error. We have also understood how to find the absolute error, how to find the mean of absolute error, then final reporting of length will be done like this. So, for this example that we were calculating here, length of pen, what is the mean value? 10.1. 10.1 plus minus 0.2. Mean absolute error is 0.2 centimeter. This will be the correct way to represent physical quantity with error. This will be correct way to represent physical quantity with error. Are we all understanding this point? How to find physical quantity, how to represent physical quantity with error? We are taking multiple readings of physical quantity, then we are taking average of these readings. The average of readings with proper significant figures, that will be called mean value. And by difference, taking difference of this mean value with every measurement and taking magnitude, we are finding absolute error. Then mean of absolute error, we are using to report error. Okay. We have also covered one example here. There are some more small points regarding errors. Sometimes people ask fraction error. Fractional error. It's very simple thing. The mean absolute error divided by mean value of physical quantity. The mean absolute error divided by mean value of physical quantity. This is called fractional error. They also call this relative error. Relative or fractional errors, same. If you want percentage term, percentage error, then multiply this with 100. Mean absolute error upon mean value into 100. This gives you percentage error. This gives you percentage error. This gives you percentage error. Okay. So, errors are the difference between the exact value of physical quantity and the measured value. There is always some difference of exact value with measured value. To minimize random error, we will take multiple readings. We can control systematic errors. We will try to control systematic errors, and we will try to minimize random error. To minimize random error, we will take multiple readings, and by taking average of this multiple reading, random errors are minimized. To report the physical quantity with proper reading, proper error, we will always report the mean value of physical quantity, which is the average of all the readings, plus or minus mean absolute error. What is this mean absolute error? It is means average of absolute error. What is absolute error? It is the difference of every reading with mean value of physical quantity and magnitude of that. So if we find difference of every reading with mean value of physical quantity and magnitude, average of this is called mean absolute error. Then whenever we report our physical quantity with error, we always report physical quantity like this: mean value plus minus delta L mean. Okay, then we can also report fractional error, relative error, or percentage error. Okay, so today we have covered some starting portion of error. Every physical quantity has some error. So suppose you are measuring area of circle. For that you will need radius of circle. You are finding radius of circle by something. Okay, suppose you know radius of circle with some error. If you are using that radius to calculate area, there is definitely some going to be error in area. Now what will be the error in area if I know the error in radius? This kind of questions now comes. Okay, that we can do in next class. In all classes we have covered up to this only. So next class we will do propagation of errors. Okay, so I hope everything this week's syllabus is I think up to significant figure and scientific notation till this only. Okay, this errors is in next week's syllabus. Okay. Okay, so let's meet in next class. Bye bye, and come prepared. You can read errors on your own also. Read by theory books, read by NCERT. Okay, let's meet in next class. Bye bye, take care everyone.